Welcome back to our channel Labs Aware, where we explore fascinating chemistry experiments and techniques. Today, we have an exciting topic to discuss: Kjeldahl Analysis. In this video, we will provide a comprehensive step-by-step tutorial on performing Kjeldahl Analysis, a widely used method for determining nitrogen content in organic compounds. So, let's dive right in. Kjeldahl analysis is a method used to determine the nitrogen content in organic compounds, such as proteins and amino acids. It's named after the Danish chemist Johan Kjeldahl, who developed this technique back in the late 19th century. There are three main steps involved with Kjeldahl analysis. First step is digestion. Second step is distillation. Third step, titration. Alright, let's move on to the step-by-step process of performing the Kjeldahl analysis. But before we start, remember to always wear appropriate personal protective equipment, such as lab coats, gloves, and safety goggles, when working with chemicals. The sample preparation. Begin by accurately weighing your organic sample. The sample size depends on the expected nitrogen content and the sensitivity of your analysis. Once you've weighed the sample, transfer it into a Kjeldahl flask. Step 1. Digestion. Add a precise amount of concentrated sulfuric acid, hydrogen sulfate, to the Kjeldahl flask containing the sample. Sulfuric acid acts as a catalyst and assists in the breakdown of organic compounds. Make sure to handle the acid with care, as it is corrosive. Now, gently heat the flask using a heating mantle or a hot plate, or a Kjeldahl digester. This process helps digest the organic matter and convert nitrogen into ammonium ions. Continue heating until the solution becomes clear or until no further fumes are observed. In this stage, we need to use these chemicals. Sulfuric is used as oxidizing agent that is used to oxidize organic nitrogen to ammonium sulfate. Sodium bisulfate is used to raise the temperature of digestion. Selenium copper sulfate catalyst is used to speed up the oxidation rate. Organic nitrogen reacts with concentric sulfuric and results in ammonium sulfate, H2O, and carbon dioxide. Step 2. Distillation. After the digestion process, we move on to distillation. Transfer the contents of the Kjeldahl flask into a distillation setup. This typically includes a condenser, a receiver flask, and a collection system to capture the ammonia gas. Apply heat or steam distillation to the flask by continuously adding sodium hydroxide, but be cautious not to boil the solution vigorously. We aim to collect the ammonia gas, not the liquid. Free ammonia is liberated from the solution by steam distillation in the presence of excess sodium hydroxide. The ammonia evolved is collected in excess boric acid with bromocresol green or methyl red to form an ammonium borate complex. Step 3. Titration quantifies the amount of ammonia in the receiving solution. A sample's nitrogen amount can be calculated from the quantified amount of ammonia ions in the receiving solution. There are two types of titration: direct titration. Back titration. Both methods indicate the ammonia present in the distillate with a color change. In direct titration, boric acid is used as the receiving solution instead of a standardized mineral acid. The boric acid captures the ammonia gas, forming an ammonium borate complex. As the ammonia collects, the color of the receiving solutions changes. Then the ammonium borate complex will be titrated with known hydrochloric acid, and when the color changes to a slight pinkish, the titration is complete. The moles of hydrochloric acid are equal to the moles of the nitrogen in the sample. And there you have it, a complete guide to Kjeldahl titration. Following this step-by-step procedure, you can accurately determine the nitrogen content in organic compounds. Kjeldahl analysis is an essential technique used in various fields, including food analysis, environmental monitoring, and pharmaceutical research. Remember, precision and accuracy are keys in Kjeldahl titration. Always ensure proper measurement and handling of chemicals, as well as following safety precautions. Before we wrap up, I want to remind you to subscribe to our channel to stay updated with more exciting chemistry experiments and techniques. If you have any questions or suggestions for future videos, please leave them in the comments section below. Your feedback is valuable to us. Thank you all for watching and joining us on this Kjeldahl titration journey. We hope this tutorial has been informative and helpful. Stay curious, keep experimenting, and until next time, happy titrating.